You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, DJ Starwatcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie is our professor of the Astronomy Lab at USM and our local protector of the night skies. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG SciSpeak, and you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Yes, certainly. So this is Friday, December 18th. So that will be the full moon. It's actually today. So the full moon for December is known as the cold moon, which makes sense because it's cold, at least up here in Maine, not in some places. And sometimes also called the moon before Yule, if it does happen before Christmas, which it will be. So this happened to be exactly 2 weeks after the new moon, and there was a total solar eclipse. I did watch it, a live feed of it from near the South Pole. A couple weeks ago. It was actually at about 4 in the morning our time, so it was kind of interesting. Only the NASA channel brought their people down there to do all the technical work, and the other channel was feeding off their channel, and then they had other people talk about, Inca astronomy from Bolivia and all kinds of other neat things, but they were using that actual feed from watching the eclipse. So the weather was perfect. It was a very interesting eclipse. It actually went backwards. Normal eclipses go from west to east because that's where the moon and the earth is spinning. This was it started in the west and then was actually going the other way because it's so tilted at the South Pole. There was a whole interesting, measurement in geometry and geography and all the other neat things. And of course now it's going to be 6 months of daylight at the South Pole. So this was the last couple of minutes of nighttime that they got. So, and there was like a huge colony of penguins down there. So there were like 60,000 penguins. And there were only 2,500 people that could go through the effort and expense to actually go see this thing. So there were far more penguins than people, so that's kind of neat. So it was a pretty dramatic eclipse without having to go through the trouble of seeing it. Okay, so otherwise the planets, we still have our 3 evening planets. Venus is getting much closer now. They're just about evenly spaced. You got Venus and Saturn's in the middle, and then you have Jupiter. Mercury is actually going to join Venus pretty soon, in a few more days, as an evening planet. And then you have Mars starting to show up next week as a morning planet. And then you might still see a few leftover Geminid meteors. They peaked back on the 13th, but you might still see a few of those. So that's pretty much what's happening for this week.
Awesome. Thanks, Bernie.
You're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. So today's show, we are looking forward to the launch of the James Webb Telescope on December 22nd, so next Wednesday. And Bernie, we have a special guest joining us today to help celebrate and kind of talk about some of the predictions that we think the James Webb Telescope will help us see.
Yes, we have Stephen Goodfellow back. He was on before. He has a Master in Fine Arts. He lives down in San Miguel, down in Mexico. And he's been on before for a couple different interesting topics we talked about. So this time he's going to share some predictions with us and some eat my hat stories that he's brought up before, because he has some slightly different views about what the James Webb may discover. So we'll have him. So welcome back, Stephen.
Thank you very much, Bernie and Sarah, and all you people out there in Podland. I am somewhat the astronomical heretic. I'm a very much a show me kind of guy. We were just talking with Bernie and talking about black holes and going into another parallel universe or something. And the Victorian in me is going, what a load of rot. Well, like Bernie and like you, Sarah, I'm really looking forward to the launching of the James Webb Space Telescope with some trepidation. We've seen the project being delayed and delayed and delayed, and now we had some plod hit the wrong wedge at the wrong time, and of course that whole spring bottom thing popped off. Yeah, I wonder if he's still there, or if they took him outside, tarred and feathered him, and ran him out of town on a rail for having done that. Of course, you know, accidents do happen. I was just before we started the shows, talking with Bernie out my trepidation about, you know, when they launched the Hubble. You know, it's really just a sort of toilet paper roll with a couple of wings that pop out with the solar panels. The Webb telescope is like a piece of origami, and every piece has to work. You know, and I mean, I'm praying that it's going to all come out right. But you know, as a friend of mine, a wise friend of mine said, expect the worst and you'll never be disappointed. So you know, if it does, so they do say, well, you know, it's behind the moon now and we can't get the panel to open properly. Well, that's it, isn't it? I mean, it's not like they're going to send up astronauts to fix it like they could with the Hubble. So it'll just be a piece of space junk out there. So let's pray that that doesn't happen. You know, not being an astronomer or a cosmologist, being an artist with just a fascination for it all, I have no pony in this race. So I've got a couple of predictions that for the James Webb, what it's going to see, and then I promise you, it's nothing like anybody else has to offer. So I call this "I'll eat my hat," and both Bernie and Sarah know the kind of hats I'm talking about. They're the diagrams you've seen for the Big Bang. And I'm wearing them on
very unique hats there. Okay, well, first thing, the Hubble was not free from any issues either when it launched. And then second, I did want to share because, you know, nothing is built into the James Webb Telescope for astronauts to be sent up to like repair or fix anything, kind of like you were talking about. And someone described to me as the James Webb Telescope does have a shield. It's called a shield of faith, that nothing will happen to it.
Where does that fit into science? But yeah, totally. You think of the amount of times they had to go up to the Hubble and twiddle a few knobs and place a few extra parts on it. I think they're more than 4 times.
There was 5 times.
5 times.
Yeah, 5 times. Yeah.
And do they have a sense of how long they expect the Webb Space Telescope
it won't
to
last nearly as long because it needs some actual fuel, because it's going to be orbiting around that L2 point. So hopefully 10 years.
Oh, that's going to be great. Oh.
Yeah, it could be as little as 5, but maybe
it
10
will
years.
show a lot. 20 times the magnification of the Hubble telescope. And they are, I think, one of the first places they're going to point it is at the event horizon, you know, where the origin of the Big Bang occurs. Maybe.
Sounds like you're excited about that.
Well, what I really like about observation is the Hubble has shown us, and I think a couple of other telescopes have been pointed at the you know, the event horizon, and what they're seeing is galaxies that are spiral galaxies, and do correct me if I'm wrong, 400 million light years young, with second generation stars. Now that just strikes me as crazy, because you think of, you know, 400 million years ago, there was life on Earth. You know, like you could go back on this planet 5 billion years. So a fully fledged galaxy in 400 million years? Are you kidding me? So I look at that and I just, it's like one of the wonderful things about the Webb Space Telescope, seeing 20 times the magnification, is that all those little hints of the galaxies far, far off near the event horizon will become much clearer. It's kind of a little bit like looking through a red fog. And the Hubble can only see sort of the brightest and fanciest sort of lights off there in that distance, whereas the Webb will be able to see a lot more. And so my first I'll eat my hat is that we're going to see a population of galaxies just like the ones around here. And the big bangers are going to have to cheat and move the goalposts further back. Oh, well, it's further back in the depths of the red limit. So that's my first. I'll eat my hat. What do you say to that, Bernie and Sarah? Any thoughts?
Well, yeah, it could change that. However, what could be happening as the universe is expanding, it could be expanding more into the same. So it could be 100 trillion light years across. But right now, what we can measure is a lot less of that.
That's my second. I'll eat my hat. Is it though? Is it expanding?
You think it's not expanding at all, right?
One of the things I've always been fascinated by is the Doppler effect, how the local galaxies around here come and go. You see blue shifted galaxies and you see red shift. If they're coming towards our little planet, they're blue shifted, and if they're going away, they're red shifted. And as you gradually go out further and further, everything goes red shift until it's at a very extreme distance. Now, I just can't help feel that we're looking through a glass onion, that what we're seeing is an illusion. I'll wear my red hat if I'm wrong.
Well, no, I don't know. I mean, I think that's what Edwin Hubble proved in 1929.
I just looked at that. You told me about Hubble, the Hubble Constant, and you wouldn't believe the amount of astronomers who are saying the Hubble Constant is in trouble because of the two different sort of approaches to one's the microwave, and the other one's observation, so that they don't overlap. So there's a little bit of a controversy there, but I think that's just chicken shit compared to what really is going on.
It's a slightly different value. See. They all agree it's expanding. They just don't know the exact rate. That's called a crisis in cosmology, and that's one of the things that James Webb is going to solve. It's going to narrow down that number much more accurately.
Well, as Bernie knows, I'm a big proponent of plasma physics, and I believe that certain plasma configurations can induce gravity, and that would throw a whole. Don't you think that would throw a whole bunch of different spanners into the work? For instance, black holes. Black holes, as we were talking about before it began, I said, nature to me, is eloquent. We see it on our own planet where hummingbirds are built exquisitely with just the right amount of matter to make them worthy of flying and being the beautiful creatures they are. And then I think of the black holes, which are just these huge big dumpsters for matter. And I just can't see the universe just chucking it all away like that. Yeah. So I'm a proponent of the idea that black holes are actually plasmoids made of much less mass than we think they are, and that they induce gravity. That we just haven't figured that out yet, that the fourth state of matter is the bridge between the gravity and the electromagnetic. And no one, there are experiments that can be performed to verify that, but no one's done them yet. So that would be my third and last I'll eat my hat, which just about like slaps everybody across the face.
Yes, I think you've already surprised us today.
Yeah, those are pretty major ones. Yeah.
So one thing though, because we've kind of talked about the Hubble and what the James Webb Telescope will be able to do that the Hubble can't do. A great analogy that I heard from someone was that the Hubble telescope is like a magnifying glass, and the James Webb Telescope is like an electron microscope. And so, you initially were kind of talking about the redshift and red-shifted light and whether or not the universe is expanding. I think we'll be able to see that we'll be able to see if we see more things, because the James Webb Telescope will allow us to see into the infrared, which will allow us to see all those really, really far away galaxies very close to the Big Bang.
Yes,
Um,
Sarah, absolutely. I mean, it's going to be so fascinating. Even if I've eaten my hat, all the books that are written about the universe today will be obsolete by the end of this decade. That we're going to see things what we never dreamed of, and that just is so exciting. And I'm so looking forward to it, and praying that the Webb Telescope will be a success. When I think about it, I mean, if I was a professional astronomer who'd written a lot of books, I would try and sabotage the Webb Telescope so that I could keep selling what I had already made.
Well, we've got you recorded. We've got your 3 predictions recorded here, right here on WMPG 90.9.
Living infamy.
In 6 months, in a year, 6 months will be when the first images come out. And maybe, a little bit while after that, we'll be able to see which of those hats you'll be eating. Or not.
Yeah.
All 3 of them.
Yeah, so anyway, Webb Telescope, looking forward to it.
I'm just going to give our listeners a little bit of the history of the James Webb and why it's so interesting and everything. First, it was supposed to be launched back as early as 2007, and then as late as 2011, and they kept moving it back. It was actually first thought of in 1989, even before the Hubble went up in April 25th of 1990. They were already starting to design a bigger scope, up to possibly even 10 meters across. So the mirror on the James Webb is 6.5 meters, and the Hubble is only 2.4. So they were thinking of designing it and building. And it was actually good that it got delayed so many times, because the technology got so much better. And now one of the big things it's going to be studying is exoplanets, planets in other solar systems. And because it can see in infrared, it's going to be able to take spectra of them and learn a lot more about those exoplanets than we ever could with Kepler or TESS or the Hubble or any other missions that we've been using. We can learn so much more about the spectra of the atmospheres of exoplanets with the James Webb. So it's going to have a big advantage there. So not just losing the time, but gaining some of the technology. And then I'll give our listeners an idea of how much has to happen for it to work correctly. Now, you might remember that 7 minutes of terror when we land something on Mars, when you lose contact when it goes through the atmosphere. Well, this is going to be 2 weeks of terror. Okay. And once it gets launched on Wednesday the 22nd, it'll be 2 weeks before it's unfolded enough to begin as it keeps doing all the things. So basically, after about half an hour, the telescope is going to separate from the launch vehicle. I mean, that's great. That's all pre-programmed and nothing's going to... So then the solar arrays start to unfold in 31 minutes. It is going to generate its own power from a solar array. They were thinking of one of those nuclear generators, that the ones that some of the other missions like Cassini have used. But instead, they're just going to have some solar panels. So it'll take about 12 hours for the engines to burn, and it's going to set the course for the L2 point, about 1 million miles away. 2.5 days, another engine burn. Now this huge sun shield, which is the size of a tennis court, which is more than just the shield of faith that you were talking about, that's going to start unfolding in about 3 days. 10 days, a secondary mirror is starting to start opening up. And then it'll be about 12 days for the primary mirror segments to start locking into place. There's like 16 segments. Everything has to work perfectly. So you're getting close to the 2 weeks. So after about 2 weeks, we'll at least know if those parts work correctly and if the telescope is together. And then it'll take 2 weeks to get to that point. So that's a month from December 22nd, so the middle of January. And then it has to be there till June to be fully calibrated and start work. So these are all the other steps we can watch very closely. At least the first 2 weeks will be really critical. If that works, it'll just take another 2 weeks to get to where it's going, and then it's just a matter of calibrating if it unfolded. But almost 400 separate functions have to work correctly. And if something doesn't, I'm sure the engineers are smart enough to make some corrections, or they can maybe skip a few things here and there or something like that. Because I remember like on one of the missions to Jupiter, a high gain antenna didn't work, so they just used a low gain antenna and they got a lot less data and everything still worked okay. So if it's something like that, we can get around it. But there's so many pieces, and so it'll be 2 weeks of terror, and then we're going to kind of have a good sense.
Bernie, you were mentioning the size of the mirror. They were actually going to go for a bigger mirror, but there's budgets and all that. Well. Just makes me think. You think of, imagine if people had the enthusiasm for the Webb telescope that they have, say, for football.
Yeah.
The amount of money that would be spent
Mhm.
on yay, Team Webb,
Yeah.
waving flags and going crazy
Yeah.
over it. But it's not in our nature, is it? It really, in terms of the amount of population that's really sort of very excited about it, is probably, very small, really.
Yeah.
Do you
'Cause
think
I
it's
know they'll
smaller
find
than the
practical things.
population of the penguins?
I know, like all the 60,000 penguins and the 2,000 people. But no, it's going to have a lot of practical aspects for everyone. I mean, you don't think of the super collider at CERN to have aspects, but we didn't think radio would either. Now look what your radio waves, even this is
Yeah,
all the radio waves. So it has lots
I
of
think
practical uses.
possibly, once the imagery and the discovery start churning out from the Webb telescope, there'll be a lot more enthusiasm. I'm sure it'll go from 1% of the population being excited to up to 2%.
Maybe 2%. It might double, Steve. Yeah. Okay. Well, hopefully it's going to more than double.
Yeah.
So Bernie, we've already kind of talked about how the James Webb Telescope will at least look back into the earliest galaxies. But do we know what some of the planned observations are in store for the James Webb Telescope?
Are you talking about the galaxies near the event horizon?
Yes.
What piqued my curiosity was the second generation stars being that close. That's very exciting. It's not what, they're in a realm where we were expecting primordial ooze, subatomic particles in the very beginnings and dawn of time, not whole galaxies.
Yeah. I don't know specifically what and how they're going to study that, but that itself would be a huge revelation, of course.
Yeah.
If they find fully formed galaxies with second generation stars like the Milky Way out there, the redshift of, whatever that redshift number is, 10 or 20 at the edge of the known universe, that's a big thing. Yeah.
I've always been fascinated in building scale models. When I was a kid, I used to build model airplanes and stuff, and I hated putting together the wrong scale. So if you had your GI Joe wouldn't go with a 72 scale Spitfire. So I was very fidgety about that. And I think went into, as I grew older, I sort of stayed with me. So, I built myself a model of the universe where I could place the galaxy, a Milky Way galaxy, on my finger. And then I said to myself, how far away is the event horizon? So, it's a fairly simple calculation. And it's been a few years since I've done it, so I might have it wrong. But I worked it out to 28 meters away. So imagine, if you will, sort of those snowstorms that happen there where there's hardly any wind, and the snowflakes come down, very, very thin, small snowflakes. If you imagine you froze that suddenly in space, in your space, so they're about this little bigger than the size of your galaxy on your finger, and you walk sort of pushing away the galaxies, you go towards the event horizon, and you come across these huge holes like Swiss cheese, the areas where there are no galaxies at all, which is also pretty amazing, and I've not heard a good explanation for either. And you've got all these interesting phenomena occurring, clusters of galaxies that are so huge that we don't have an explanation for how, their scale and size in comparison to the size of the galaxy. And when you finally get to the red limit, and you're looking at these galaxies that they're seeing, they're only like 80 centimeters away from the from where we can't see any further.
Yeah.
That's really close. And that sort of model just makes me gives me food for thought. I've got other models, but I won't tell you about them.
Other models. You do that next time. Yeah.
Bernie, did you have any predictions as far as exoplanets goes? Because I know that's something that the James Webb will be.
Well, I don't know if it'd be quite sensitive enough, but it'd be nice if they could detect all the, materials for organic material and water in the atmosphere and all around an exoplanet, other than maybe any kind of a human type signature even. But it'd be nice if they could find that. Pretty much proof of life on other planets. The Goldilocks zone, of course, all the other things they have to have for liquid water on the surface. But that'd be pretty great discovery.
Steven,
Bernie, would you say that the Webb telescope has any relationship to the Kepler Space Telescope in terms of? Yeah, go ahead.
Kepler, I mean, it stopped functioning, but it was looking for planets, exoplanets, just in the area of Cygnus. And then the TESS was looking at a wider part of the sky. And now the Webb will be able to do that in infrared and get more detail. Like we had a space telescope called the Spitzer. It was looking at stuff in infrared, but it ran out of fuel. You need coolant to cool the mirrors down to almost 0 degrees. So that's one reason that the Webb's lifetime will be somewhat limited just based on that. It's not going to last for 31 years like the Hubble could. Hubble didn't need that sort of thing. But yeah, so I think I'll find that. Plus, I might find out somewhat of the nature of the dark energy. I know you think the universe may not be expanding, but if it is, this is an anti-gravity force, and it could define that, and we're certainly looking for dark matter. I know a physicist personally who set up an experiment, so if we find something of what dark matter could be, or even a bit of a clue, or, that would be another great discovery. These will be all Nobel Prize winning discoveries once the people analyze the data, starting about the middle of next year, as soon as that.
Yeah, I've been following that paper after paper over the last 5 years, looking for dark matter, and coming up pretty much a blank is exciting.
Yeah.
I mean, the fact that it remains a mystery is what's so tantalizing about the field of astronomy is it's not a boring subject at all, and things are always occurring that make you go, what the heck? How could that possibly be?
Yeah.
I love that quote. I forget who said it though. Is only the fantastic will occur, and I just love that quote. So if you could ever find out who gave that quote, I just think it's such a suitable one for cosmology and astronomy.
Yeah, I mean, I think that says a lot about, with Hubble, I think, some people didn't have any expectations about what we were going to see, and the things that we did see kind of was mind-blowing at the time anyways. So who knows what we'll see, especially in the infrared. Maybe we'll see so much more than we could ever even imagine.
Yep, I think we will. All the books will have to be rewritten. Even if they were basically correct, they'll have to be rewritten.
Yeah.
Because there'll be so much more now.
Yeah. It's like a whole nother section of the book that doesn't even exist right now.
Yeah.
So volume 2.
Yeah. And then 3 and 4, and then we'll have future generations of space telescopes beyond James Webb, I'm sure. So that too we got to consider.
Yeah.
And I feel blessed that we're living in such an exciting time. Can you imagine if you were living in the dark ages, you're plowing your field and wondering what's happening over the horizon line. And here we are, the three of us looking at each other, Dick Tracy, be gone. It's more fantastic than I ever thought it would be.
We're thousands of miles away, and we can do all this. And I could watch the solar eclipse from the South Pole. I'd never go to the South Pole and with all those penguins. I could see that. That's pretty neat.
Well, that is a very positive note to end today's show on. Thank you so much, Steven, for joining us, for sharing with us your 3. Yes, we will go back to this once the James Webb Telescope comes out with its first images, whatever that looks like, and see what we find about your 3 eat your hats.
It's going to be very exciting, and I wonder how it'll taste.
Absolutely. You've been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Steven. Stay tuned for Something for the Weekend with Anella, and from your favorite nerds, just a reminder to vaccinate, mitigate, and then we can all congregate.